Let's do some math for fun. Today we are going to do some more integration shortcut, which is these two equations. That is the integral of e power of ax times sine of bx dx and e power of ax times cosine of bx dx. And we are going to try to solve these two integrals using integration by parts. And as you guys know, in calculus, these two integrals is pretty famous, and it will be a waste of time if you don't know what is the general formula of these two, because if you use the integration by parts, you still need to take more time than just use the shortcut. You can just straight away plug in the suitable value of the given integral of this kind of form. So here's how. So let's start to solve these two integrals using the integration by parts. So let's solve the integral of e to the power of ax times sine of bx dx. So as I said, so here's how you solve this integral using the integration by parts. So we got a differential column and then the integral column, and then we are going to extend this plus minus sign, and that's because in the end we are going to meet the same thing when we multiply the row. So I will let e to the power of ax in the differential column because that's more easier, and sine of bx at here. So we differentiate e power of ax, we get a times e power of ax. And if we integrate right here, I will get negative 1 over b cosine of bx. So this is just basically a simple integration. So you can just use some simple substitution, plug in your mind, so that you can save a lot of time rather than just write more. But you can write more in order to prevent mistakes. And if you differentiate this once again, you get a squared times e power of ax. If you integrate this once again, you will have 1 over b squared negative 1 over b squared times sine of bx. And stop, we are done. Because what we got right here is, when we multiply the row, we got the same thing. This is just a and b, is just basically a constant. So for here, we are stopped. So this one is equal to e power of ax. So we are just going to multiply it diagonally. So this is equal to negative e power of ax times over b times cosine of bx, and then plus a times e power of ax over b squared times sine of bx, and then minus the integral of the product of the row. So multiply it, since a and b is just a constant, so a squared over b squared is just a constant, times e power of ax times sine of bx dx. And look at what we got here. Since this integral is equal to this one, and we got the integral repeated on here, which means we can treat it as an equation. So we can just take this term to the other side, become plus, and these two become like terms. So I will have 1 plus a squared over b squared times the integral of e to the ax times sine of bx dx is equal to a times e power of ax over b times sine of bx minus e to the ax over b times cosine of bx. And then we can group it as a simple fraction. Then I will have a squared plus b squared over b squared. And then since it's a constant, all I need is to find this integral, so I can take this one to the other side. So the integral of e to the ax times sine of bx dx is equal to, and at the same time I can factorize the e power of ax. Why can, so we can just factorize it out. So e to the ax, and then over a squared or plus b squared times b squared times a times e power of ax over b is equal to times sine of bx minus e power of ax over b times cosine of bx. And then we are just going to multiply the b square, expand the b square, then I will have, okay, sorry guys, so this one multiply this one, I should have, yeah, okay, so sorry guys, I forgot the square as the previous one. And then we are going to multiply that. This is equal to e to the ax over a squared plus b squared times a times cos times sine of bx minus b times cosine of bx. So this is the shortcut for the integral of this one. Now let's jump to the integral of e to the ax times cosine of bx dx. Now let's find the integral of e power of ax times cosine of bx dx using integration by part. So we got the differential column and integral column. So I will write plus minus plus, and then this one doesn't have any more. And then we are going to let e to the power of x to be differentiate, and cosine of bx to be integrate. And then with differentiate, I will have a times e power of ax. For the other side, I will have 1 over b times sine of bx. And then once again, if you do another here, I have a squared times e power of ax, and then negative 1 over b squared times sine times cosine of bx. So this one is equal to, so we multiply right here, and then we multiply. So this integral is equal to e of ax over b times sine of bx plus a over b squared times e power of ax times cosine of bx. And then minus the internal, minus a squared over b squared times the integral of e to the ax times cosine of bx. And once again, this integral is equal to this one. And since we got the same integral, right, as right here, which means I can treat it as equation. and take this to other side. So and then we have like terms, which is e power of ax, the integral of e power of ax times cosine of bx dx plus a squared over b squared times e power of ax times cosine of bx dx. And then these two terms are like terms, so we can actually factorize the integral of e power of ax times cosine of bx dx out. So I will have 1 plus a squared over b squared times the integral of e power of ax plus cosine of bx dx is equal to e to the ax over b times sine of bx plus a times e power of ax over b squared times cosine of bx. And then what we're going to do is we are going to group it, and I'm sorry that I forgot to write the close bracket. And as you guys can see, and if we take the constant to the other side, we will get what we want. So the integral of e power of ax times cosine of bx dx is equal to, now at the same time we can just actually factorize the e power of ax out. So e power of ax over a squared plus b squared times b squared times 1 over b times sine of bx plus a over b squared times cosine of bx. And then expand the b square, I will have e power of ax plus over a squared plus b squared times a cosine of bx plus b times sine of bx, and we are done. So this is the integral. So this is the solution to the integral of e power of ax times cosine bx dx. So you gotta better remember these two, because if they do not tell you show the solution to the question, then you can just use shortcut, because they will save time, unless they tell you to show your calculation or whatever. But if they not show, just use the shortcut in order to save time, so you can solve the integral more quickly. And as always, if you guys enjoyed this video, leave a like and subscribe to my channel for more upcoming videos, and I will see you guys next time.